Okay, we're looking at another type of differential equation today. This will be the last one that we'll solve algebraically in this course. So we've talked about group 1 types where it is in terms of the independent variable. Group 2 is in terms of the dependent. Group 3 is in terms of both. And we basically separate those variables. And the homogeneous, we can show in terms of both, but we can show it as a function of y over x. And now we're looking at these ones. So it says circle the differential equations solvable using one of those techniques. So basically you'd want to, let's quickly just solve for dy dx. So that would be cos x minus 2xy over x squared. So there's x's and y's, but we can't show it as a function of y over x, and we can't separate them. So that's not going to work. Dy dx. Okay, can't separate those. We'll show it as f of y over x. Same, can't do that there. Now we could factor out an x here. So let's see, that'll be 1 plus 2y. So that we could separate. Okay, 1, so basically 1 over 1 plus 2y dy equals x dx. Okay, so that one we can do. This one will be, let's see, x squared minus 2xy. Let's factor out an x, but unfortunately there's an x in the brackets there, so we can't do that one. And this. Just do this all at once. Now, what could you do? You could split that up. There's no like terms. Still got a y. Yeah, so I'm not going to be able to do that one either. Okay. So we're going to learn how to solve that one that's circled. Okay. Oh, sorry, the one that's not circled. All of them, but we'll start with the first one. So this is the left side of the first example there that we don't know how to solve yet. So looking at that, now we can show it with the prime notation like this. That's all that it is. Look at it carefully. It doesn't look like it could be the result of a familiar process. Okay, so what is it? Got a hint here, absolutely. So x squared times the derivative of y with respect to x plus 2xy. So whenever you get two terms, it's usually from the product rule. So what would that be the derivative of? Okay, so we have to have x squared and a y. So x squared times the derivative of y with respect to x plus y times the derivative of x is 2x. So that is the left-hand rule. So that left-hand side. So that's the product rule. Right, so derivative with respect to x of x squared y is equal to that. Okay, so this will be helpful in finding the solution to that first differential equation, because now what we have here, the left side is this. There's your right side. Okay, so if the derivative, if we're taking the derivative of x squared y, then if we take the integral of that, so the left side is the derivative of x squared y, the integral will be x squared y, and this will be cos x dx. Okay, so we can remember taking the integral is the inverse of taking the derivative. So then x squared y integral of cos is sine. Okay, and then if we were to solve for y, there you go. Okay, so that's what we're going to sometimes be able to see. The problem is sometimes it's hard to tell what the original function was to give that left side. Okay, that takes sort of, you're working backwards. It's kind of too much work to go about doing that. So we want a method that will help us. So that's what we're going to look into here. So the differential equation that we just did is called a first order linear differential equation. The equation has this form. So some function in terms of x may just be a constant, but it's some function in terms of x, not y, times dy dx plus another function in terms of x times y equals another function in terms of x. When both sides are divided by f of x, so we're kind of sort of trying to get back to dy dx, it can be written in this form. So here, when I divide g of x by f of, well, the first term, the f of x's go away, g of x divided by f of x, now we're calling that p of x, right, when we do that dividing. Then h of x divided by f of x is now called q of x, right? So we're just rearranging it, and now we're going to look at those particular functions, p of x and q of x. All right, so here's another one. We've got x cubed. Now this one again is something that maybe you can work backwards and figure it out, but we want a method to do it for all differential equations. So solve the equation for dy dx. So if we do that, we're going to will be x to the fourth minus 3x squared y over x cubed. Okay, let's simplify that. So x squared goes into everything. Okay, we can split that up into terms, but looking at that, if we were trying to solve that, seeing what group it's in, it's not in any of the groups. It's not a homogeneous. So then what do we do? Okay, so is dy dx equal to just f of x? So we're just going through. That's the group 1. So this is group 1. No. Is it part of group 2? No. Can we show this as y over x? No. If this was x minus 3y over x, we could, but we can't here. So it's not group 3. And are they separable? Oh, that's not group 3. That's homogeneous. Anyway, variable separable? No. All right. So that's why we have to come up with another method. So no to all of the above. Perhaps it's a linear differential equation. Let's see if we can express the left side as the derivative of a product and then solve. So this one, as I said, pretty straightforward. You can kind of tell it's going to be the derivative with respect to x of x cubed y, okay, is the left side, because x cubed dy dx plus y times 3x squared. So that's equal to x to the fourth. So that means x cubed y is the integral of x to the fourth dx. So that's x to the fifth over 5 plus c. And then we want to solve for y. So we're going to x to the fifth plus 5c over 5x cubed. Okay, and I would just leave it like that rather than separate it into two different terms. Okay, so now we're going to get into ones that are pretty hard to tell. So this one here, just change on your sheet. This should be, if you follow down, it's not going to be 3x, it's just x. Okay. In any case, let's look at this one. Ask yourself the usual questions. So is dy dx equal something in terms of, oh, so let's solve it. So dy dx equals 4 sine of x plus y all over 2. Okay, so it's not just in terms of x, it's not just in terms of y. I can't show it as a ratio of y, a function of y over x, and I can't separate it. All right? So let's see if it's a linear differential equation. So there's the function. So just realize that you can, if you get rid of the factor with dy dx, still keeping the term on the left, so one term on the right, that's what it would look like. We'll get to that in a sec. So is the left side the result of differentiating a product? Okay, I don't think so, right? Like, it's not going to, if you think, okay, maybe it is 2y, that would be 2 dy dx, but then there would be no other term, right? So no. Does it mean we're finished? Well, we're not sure. We're going to try to see if we can come up with, see if it's a linear differential equation a different way, okay? If it is a linear differential equation, then we can multiply the equation by some factor such that the left side would be the result of differentiating a product. So that's what we want to make the left side be the result of differentiating a product. So we're going to have to multiply through by something. Okay, so here's what that something is called the integrating factor. So find the integrating factor. What do we do here? So notice how this has no coefficient in front of dy dx, so it's just a 1. So now we're calling that p of x and q of x. So let's assume the integrating factor, we'll call it u. Okay, so we're going to, factor means you're going to multiply everything by u. So that means every term here gets multiplied by u in terms of x. Okay, so the integrating factor is this, e to the integral of p of x dx. Okay, where integral of p of x dx is the simplest meaning that our constant is 0. Now, why is that? So let's take a look. Okay, so let's take a look at the left side here. If we take the left side and so if we have u of x times y, and we want to take the derivative with respect to x of that, that's going to be u of x dy dx plus y times the derivative of u prime of x. Okay. So then that means down here looks the same. This is the same. This is the same. Y is the same. So u prime of x is the same as u of x p of x. Okay, that's why. Right. So we have to figure out. What u is going to be. So if we rearrange this equation, p of x is going to be u prime x divided by u of x. Okay, then we think about, all right, well, how do we get u prime x over u? That's the same as the derivative of ln of u of x. Because remember, the derivative of ln is 1 over the argument. So that's going to be 1 over u times the derivative of u prime. Okay, so then if we want to get ln of u by itself, take the integral. Okay, and then get u by itself. It's going to be e to the integral p of x dx. So now we figured out what u is. So we need to know what p of x is. Once we know that, we can find the integrating factor u of x. Okay, so in general, to solve a linear differential equation of this form, so you want to get the coefficient of dy dx to be 1. Keep this term on the left. So you would then multiply the equation by the integrating factor. And then the left side of the equation will be the result of differentiating the product. All right, so let's practice. Well, I guess we'll finish off the one that we were doing, right? So remember, we want the coefficient to be 1. Okay, so then integrating factor. So just show it somewhere. Even if you abbreviate it, you can. So that's going to equal e to the integral of negative 1/2 dx. Okay, so that coefficient of y. So what's that going to be? That's going to be e to the negative 1/2 x. Okay, plus c, but remember we're taking the simplest, so c would be 0. You can show that as e to the negative x over 2 if you want. Okay, so now we're going to multiply both sides by that. All right, so what is this? What is this the derivative of? Obviously, it's got to have e to the negative x over 2 in it. It's got to have a y. And then let's make sure that coefficients are correct. So e to the negative x over 2 times y prime minus, yep, that's good. All right, so now all right, so we have to take the integral of the right side. Sadly, it's not straightforward. So you're going to have to integrate by parts. So I'm going to let u equal, you can bring the 2 out. Because it's a half in here, I'm going to leave it in because I know it's going to help simplify a little bit. Okay, so u and then dv is sine of x dx. So du equals negative e to the negative x over 2. V is cos. Oops. Okay, so I'm actually going to do this work on the side for this integral. Okay, so the integral of 2e to the negative x over 2 sine of x dx equals uv. So negative 2e to the negative x over 2 cos of x minus the integral of v du. So negative times negative is positive, so that stays. And you'll notice, oops, I forgot the dx here. You'll notice that it's not a whole lot simpler, but anytime you have sine or cos, remember it's going to alternate. Probably we'll have to do this twice and solve the equation. So now I'm going to call this u1 equals e to the negative x over 2. u1 is negative 1/2 e to the negative x over 2 dx. And then dv1 equals cos x dx. So v1 equals sine x. So now you have a lot of space on your paper. I'm going to do it on the side. Maybe you want to do this underneath. All right, so minus uv minus the integral of v du, so that's going to be a plus, and then 1/2 e to the negative x over 2 sine x dx, all right, which the left side has e to the negative x over 2 sine x dx. So I'm going to get rid of the big brackets. Don't like fractions, we're going to multiply everything through by 2. Okay, so that's going to equal 4. Negative 4 e to the negative x over 2 cos x, and then minus 2 e to the negative x over 2 sine x, and then plus e to the negative x over 2 sine x. There we go. Okay, then gotta fix the sign there. Minus. So bring that over to the left, and this should not be an equal sign, it's just an arrow. And so that's going to be 5 e to the negative x over 2 sine x dx equals negative 4 e to the negative x over 2 cos x. Okay, and now our right hand side originally is 2 of these. So basically I want to multiply by 2/5. Both sides. Okay, so then you can show this all as one fraction for now if you want. 4. Okay, so I'm going to put this back in here. Okay, plus c. And then you can factor out, and you'll notice there's an e to the negative x over 2. It's a common factor. And then that would be negative 8. I'm going to show it as separate terms. Okay, plus c. Then we're going to want to isolate for y. So really, you're dividing by e to the negative x over 2, which is the same as multiplying by e to the positive x over 2. Both sides. So that goes away. We got y equals, so this times the first is just going to be negative 8/5 sine of x minus 4/5 cos of x, and then it's going to be plus c times e to the x over 2. Okay, and that's it. So when you're thinking about, when you're going through this, first step is to divide by the coefficient or the factor in front of dy dx. Then you take your factor with y to find your integrating factor. Multiply through everything by it, And then you should be able to get that product rule, the original product that gives you the left side.